morning children. Welcome to the Physical Science Digital class. Children, you learned about the plants, animals and types of motion, electric bulb and changes, chemical changes, metals, non-metals in your science subject. In this 8th class, you are going to learn about the plants and animals as a bioscience subject and the remaining types of motion and electricity like magnetism, chemical changes and physical changes in physical science subject. Children, you learned about the changes around us in your previous grade like motion of planets, water cycle, like that is solar system, and water cycle, that is raining process. And also children, you learned about the natural changes like sunrise, flow of river, change in seasons. Children, you heard about the news about natural disaster, that is earthquake, tsunami and cyclone formation in seas, volcano explosion. Our ancestor believed that some invisible forces exist in this universe which causes all these whatever the happening in this universe. Let us consider some of our daily experiences like brushing, eating and doing exercise, playing, riding bicycle and doing homework and running. And also children, in the actions like picking, jumping, running, closing, opening, shutting, in these actions usually changes motion of the object occurs. Let us learn about force in this chapter. Observe this table, children. Given here some of the actions. In this action, which action is involved? Either pull or push or both. Here the camel, here the load cart is attached to the camel, and in this action to move this load cart, the camel has to pull the cart. So here the pull action is involved. Come to the next example. Here the boy playing with the toy trolley in the beach. So to move this toy trolley, the boy has to pull the trolley. So in this scene also pull action is involved. And the third example, observe here children, the boy pushing his mother who sat on the toy rider. So to move his mother, he has to push her. So here in this scene, push action is involved. Come to the fourth example, that is here observe children, here the bird is going to fly. So to fly, the bird has to push the air in downward direction with its wings. So in this action also push is involved. Come to the fifth example. So we are very familiar to this action, that is archery sports. So here the shooter, before going to release the arrow, she has to pull the arrow along with the bowstringer in backward direction, and after the bowstringer pushes the arrow in forward direction. So in this action pull and push both are involved. And come to the last one, that is, this is, you know children, this is cricket. Everyone plays cricket. So in this the batsman going to hit the ball. So before going to hit the ball, the batsman has to pull his bat in backward direction. Then after he has to push the bat in forward direction to hit the ball. So in this action also pull and push both are involved. Children, in your textbook the table is given. So you have to write which action is involved, pull or push or both, in the table. Above all these examples, we can define the force as force is pull or push upon an object. Force is pull or push upon an object. See here, the person is pushing his chair in forward direction. To move the chair in backward direction, the person pulling the chair. Based on the physical contact between the object, a common classification of forces are given. Two types are given here, that is, one is contact force, and other one is force at a distance, also called a non-contact force or force at a distance. The force is classified into two types, that is, one is contact force and non-contact force, also known as force at a distance. What is this contact force and non-contact force? Contact force. The force occurs on account of direct physical contact between two interacting objects. The force occurs on account of direct physical contact between two interacting objects. For example, to hold this pencil, there is a contact between pencil and the fingers. There is a physical contact between pencil and fingers. So to write on any paper, so the pencil lid has to be in contact with the paper. Examples are muscular force and friction force. Muscular force means, you know that children, to do action we have to use our muscular force. And friction force, we'll going to learn about this muscular force, friction force and more about contact force later. Force at a distance. So what is this force at a distance? So the force exists between two interacting objects without any physical contact, known as force at a distance. Examples: magnetic force, electrostatic force and gravitational force. Children, you know about magnetic force, that is, magnet attract the things. Magnet attract the things at a distance. When you keep the coin at a distance, so it pulls the coin. It pulls the coin without any physical contact. So magnetic force is the best example for the force at a distance. Force at a distance are non-contact force. So the first example is, I have taken here magnetic force because of you are very familiar with these magnets. You learn about the magnets in your previous grades, that is types of magnets like bar magnet, horseshoe magnet, ring magnet and disc magnet. So, and you also know that, children, so every magnet has two poles, that is north pole and south pole. For every magnet there are two poles, that is north pole and south pole. To understand more about these poles of magnet, let us do an activity. For this activity we need a bar magnet and two pins and four cork balls. Two are in blue color, two are in red color. And I need a water trough. And I need water trough. To identify the magnetic poles, I need a magnetic compass. See, what is magnetic compass? You know, children, the magnetic compass shows the directions of geometric directions of Earth, that is north and south pole. See here, the red needle indicate, the red color indicates north pole and the colorless is indicate south pole. So magnetic compass always shows the north and south directions. First we take the needle and with the help of bar magnet just rub the needle from one end to other end with any one pole of the bar magnet, like this. Children, you have to observe here, we have to rub this needle continuously in the same direction. So when the needle is get magnetized, it forms north pole and south pole. So to identify the north pole and south pole, just keep the magnetic needle near to the magnetic compass. See, the deflections are showing by the magnetic compass. So it is repelling the south pole. So that's why I am pinning this with blue color cork ball and other end with red color cork ball. And keep it on surface of water and see how the needle is aligning in the direction of north and south pole of the earth direction. See, the magnetic compass showing the north pole in this direction. So here also the needle end, this red cork ball end is showing the north direction, and here this end is showing the south one, and the blue end is showing the south one in the same direction. In the same way, magnetize the other needle with the help of bar magnet. That is, this method is known as one touch method. From end to end, rub the needle with the help of bar magnet. Children, don't change the pole of the magnet. Magnetize the needle continuously. You have to rub with only any one pole only. Now, to identify the poles of this needle, just keep it near to the magnet. See, it is attracting this one. So attracting means, attracting south pole means this will be the north pole. This will be the north pole. So I am pinning with this red color cork ball and other with the blue color cork ball and placing on the water surface. See what happened. See, the two different colors are coming closer. Means this is north pole of this magnetic needle, and this is south pole of this magnetic needle, and these two ends are coming closer, means they are attracting each other or pulling each other. So I'm trying to separate these needles, and I'm trying to keep the both same ends close to each other, but it is not happening. It is not happening. So again, the two different color ends are coming closer, means the attraction force, and two same colors are moving away from each other, means they are repelling each other. That is, from this experiment we can generalize that like poles repels. Like poles repel. See here, children, north and north pole both are repelling each other, and south and south. So repels means pushing away. If you take unlike poles, that is north pole and south pole, they attract each other. They attract each other. And here south and north pole pull each other. What is meant by attract? That is pulling together. Like poles repels, unlike poles attracts. So children, magnets are used in our daily life, like construction of magnetic compass. Magnets also used in electric motors. In magnetic train technology also we use the magnets. And observe here, so the magnetic levitation, that is a ball. See here, the object is in the air without any support. See this picture, children. In the first picture, so here the girl holding the balloon, and when the balloon is near to her hair, so the balloon is attracting her hair. And up to the second picture, the boy is sliding on the plastic slider. So observe his hair. So his hair stood in the air. So observe this third picture, that is cat. The cat's fur is completely covered with thermocol pieces. So the cat jumps into the thermocol pieces. So all the thermocol pieces are attached to this cat. What is the reason behind this? Even children, when you are combing your hair, so the comb attracts the hair. You can observe, and you might have observed when you sit in the chair, your hair which is on the skin stood in the air. So what is the reason behind all these things? So children, this is due to the electrostatic force. What is this electrostatic force? So we can define the electrostatic force as the force exerted by a charged body on another charged body is known as electrostatic force. What is meant by this charged body? Children, you know that you know about the battery. The battery has a positive charge and a negative charge. So when the body has a positive charge and the other body has negative charge, both are attracts. Like north pole and south pole of the magnets are attracts. When the both bodies are same charges, means both are positive charge or both are negative charge, then they repel each other, like poles of the magnets repels each other. About electrostatic force we learn in the higher classes, children. So let us observe the next example. The apple tree is there. So when the apple comes down, that is, apple falls down. Why the apple is falls down only? Why the apple is not moving upward direction. It is falling on the earth only. When you throw an object, here the ball is there, so when you throw the object in the air, it is again falls down. Why it is happening? So children, you are very familiar with these activities because of you always plays with the stones. When you throw the stone into the air, it is comes down again. So what is the reason behind this? You already studied about this, I think, children. So that is gravitational force. That is gravitational force of earth. This is explained by Sir Isaac Newton in 17th century scientifically. So this force is gravitational force. Without any physical contact, the earth attracting the things. Is only earth attracting the things? Is only earth has gravitational force? No, children. So every massive object possesses gravitational force. That is, the force exists between two massive objects. The force exists between two massive objects when it is separated by a distance is known as gravitational force. So every massive object possesses gravitational force means what? Eraser and pencil, it has mass. It has also mass. So means this eraser also possesses the gravitational force. So if the eraser has a gravitational force, attraction force, then why it is not attracting other object? If the pencil has mass, the pencil has also its own gravitational force, then why the pencil is not attracting the eraser? And we cannot find any attraction of these forces. Even when your body also have the mass, your chair, the table and the things whatever you are observing around you having the masses, you are not observing any type of attraction force by them. So why it is not happening? Why we feel only earth gravity? That is because of the eraser and pencil, whatever the things on the earth are there, they have the less mass compared to the earth mass. Earth has extremely high mass. Earth has extremely high mass, then we can feel, we can experience that gravitational force. Gravitational force, electrostatic force and magnetic force. These are the field forces. These are called field forces because of without any contact, physical contact between the object, they can attract the other object. So what is this field? The field forces. Why it is taken as a term field? Because of children, observe here, I am taking the bar magnet. When you keep the 1 rupee coin little far away from the magnet, it is not attracting. There is a separation between these two objects, but the magnet is not attracting the coin. But when you bring it some little bit closer to the magnet, then it attracts. Means what? So up to this region only, the magnetic force is influences. The region around the object where we can find or we can detect its influence of force known as field of that force. Out of this region, so there is no any effect of force. Field is 3 dimensional, that is, so earth has atmosphere. The atmospheric particles are under the gravity of force. So we can say that the earth gravitational field is 3 dimensional. If you go in US, if you go to the China, if you go to the Australia, you will find the atmosphere everywhere. So the atmosphere is surrounded by the earth. Gravitational force which is produced by the earth is 3 dimensional. Electrostatic force and gravitational force and magnetic force are the field forces, and these field have the limited range and have 3 dimensional. These are the 3 dimensional. Children, let us discuss about the contact force. Observe this: to hold the books, to carry the things, in playing, when you kick the ball, to kick the ball, and here caroms, to strike the carom coins. So in this all we need muscle force. We need muscle force. Not only in this, in every action like brushing, eating, doing, lifting, lowering, every action we need muscle force. Muscle forces are the responsible for the organic functions like in our body, like blood circulation, contraction and expansion of lungs during breath. and these are the muscle force. Is only muscle force is required to hold the pen. So what happen if some oil is stick to the fingers? It is slip away from our fingers. We are not able to write. Feel it is slippery. So means not only the muscle force is responsible to hold the things and to do the actions. Some other force is also exists. That force is friction force. That force is friction force. See children, we can define the friction is the resistance to the movement of a body over the surface of another body. Friction is the resistance to the movement of a body over the surface of another body. When you given a push to the object moves and comes into rest after some time. So why it is comes into rest? Because of there is a frictional force developed between these two surfaces of the object, that is this block and the table. So here observe here this arrow mark. So here the frictional force is developed to stop this object. Friction is depends on the surface. It is the nature of surface. Let us do some small activity. I am keeping an eraser on this plank and one coin. So I am just lifting from one end of this plank. See what happened. The coin slides down but not eraser. Why it is not happening? So the friction is depends on nature of surface, means the eraser surface is rough. Due to this reason the friction is more. Even when you lift the plank, the eraser is not moves. But the coin has a polished surface. It can slide on the plank, means the friction is less for polished surface and more for rough surfaces, means friction depends on the nature of surfaces. And next children, observe here, the book is kept on the table. What forces are act on it? Yes, there is a gravitational force acting in downward direction, and as well as to keep the book in rest state, there is a friction force also exists between the surface of book and a table. Children, what happens suddenly the table is disappears? Yes, the book will falls down. The book will falls down. Means what force is responsible to keep the book in stable on the table? So there is another force which is act on the book in upward direction equal to the gravitational force, that is known as normal force. Normal force is a contact force which acts at a contact point and perpendicular to that point. Children, you have to notice that normal force is always act at a contact point where the object is in contact with the surface. So at contact point the normal force is acts and perpendicular to the surface. So to stand stably, so normal force is act in between our foot and the ground. So to keep the objects on the earth stably, normal forces act always at a contact point. Children, I want to keep this ball in the air. So if you want to keep this ball in the air, it will falls down. It will falls down. So I want to keep the ball in the air, so I can take the help of a string. There is no any contact with the surfaces, means there is no friction force, there is no normal force. Now which force is responsible for the ball to be in the air? So there is a gravitational force act in downward direction, and also some other forces act along this string. That force is known as tension force. So children, here a block of mass is hanged to the string, and there is a force developed along the string in upward direction opposite to the gravitational force. Force developed along string opposite to external force is known as tension force. If what happen if you add some load to this string, some more load, some more and more, so add some 1 kg stone to the string, is it bear? No. So every string has a limited or a maximum weight which can borne by the string. So different string has a different maximum weight. Why we have to learn limiting force? because of in the preparation of brake wires, in the preparation of ropes which are used to lift the heavy weights by the cranes. So these ropes have the different limiting forces. So to sew the cloths, we need the light string like a cotton and silk threads. In the cradle we use the ropes, and in brake wires we use metallic wires. In cranes we use metallic wires. Based on the requirement we use the different types of strings. So limiting force is the maximum external force or weight which can borne by a string is known as limiting force. After this force, if you increase the load or if you increase the external force, the string will break. Let us do a lab activity to find the limiting force that can be borne by a string. For this we need some materials, that is spring balance, weights, light string of 10 cm length and of equal thickness, and weight hanger. So this is the experimental setup, students. So this is a table, children, you have to note it down. So at what force the string will break up, that weight you have to write here. So first of all I took the cotton string and I'm adding the 50 grams to the load. Already it is 50 grams, so it is showing the 50 grams, and when added the again more 50 grams and it is showing the 100 grams. Now adding more weight to this and it is showing the 150 grams, and adding some more weights to this string, it will break, and again the reading shows the 0, means at 200 grams the string will break. So 200 grams is the limiting force borne by the cotton string. So like this you can repeat the experiment with the different types of string like silk. You can take your hair also. These are the concepts you learned in this session, and about the force effects you will learn in the next sessions. Let us review of these concepts once again, children. Force is pull or push upon object. Forces are two types, one is contact force and the other one force at a distance. A contact force is a force that requires contact to occur. Examples: muscular force, friction force, normal force and tension. Force at a distance is a force which do not require contact to occur. Examples: magnetic force, electrostatic force and gravitational force. Force at a distance is also known as field forces. Friction is a contact force which opposes the relative motion. Normal force acts at a contact point and perpendicular to the contact surface against the gravitational force. Tension force is a contact force which acts along the rope and or string and opposite to the external force. Children, these are the concepts we learned in this session. So let us try to answer these questions to improve your learning. So the first question is, what is force? And next task for you is, that is, list out various examples for which activities involves pull or push or both. So there is a table in your textbook also, you have to fill that, and give few examples for contact force and non-contact force your own. So draw the normal force direction which act on object kept on inclined plane. What is friction? Explain how friction advantage to us. What is tension force? So children, about this you have to practice. Thank you.
వీక్షించండి రెట్రో టైంలో. ఓం నమ శివాయ్.